Welcome back to Get Ahead Learning. This video will discuss these devices you see here called capacitors. I'm Mr. Gal. Thank you so much for joining us. If you like what you see, please consider hitting the thumbs up, subscribing, and click on the notification bell. I really appreciate you being here, and without further ado, let's get to it. This is going to be the first of several videos addressing capacitors in electric circuits. In this video, we will gain an understanding as to what a capacitor is, bring attention to some of the possible functions that a capacitor could have in a circuit, and lastly, understand what is physically going on the level of an electron as a capacitor charges. In future videos, other objectives will be met as well. So what is a capacitor? Well, it's a device that holds charge separate, and thus, with the separation of the charge, it stores electric potential energy. A capacitor consists of two conducting plates, which can be described as having an area. There is a distance between the plates, and either a vacuum, air, or some insulative material is sandwiched between the two plates. The physical parameters is what determines a capacitor's capacitance, and once it's made, that capacitance is a constant. This first part here, that's going to be like the physical parameters to the actual capacitor, right? It's going to be the area of the plates, the distance between the plates. The K you see there is called the dielectric constant, and that's going to be particular to the material, the insulated material that is between the plates. And then you have the permittivity of free space also. It is these physical characteristics to the capacitor that determine its capacitance. And like I said, once it's made, it's constant. Now, a capacitor has a relationship to both the charge on each plate and the voltage across the plates as well. And that's going to be this guy right here, right? The capacitance is equal to the charge on the plates divided by the voltage across the plates. And the unit of measure for capacitance is farads F. This middle picture shows you what a capacitor might look like in an actual circuit board. What it is two pieces of conducting tape or thin material that's conductive, and sandwiched between them is the dielectric or the insulative material. This diagram to the right gives you the details as to what it would look like. The plates don't initially have any charge on them. They're neutral. They have as many electrons as they do protons. However, when you hook it up to a battery, one side to the positive terminal, the other side to a negative terminal, electrons will start to move due to electric forces. Ultimately, one plate ends up being positively charged, the other plate ends up being negatively charged. That charge on either plate is the same magnitude. And across the plates, there is going to be a voltage from one plate to the other. So what is the function of a capacitor? How can it be used in a circuit? Well, a capacitor stores energy for future use. Capacitors can be used as a temporary power supply. A capacitor may be used to supply power for a brief amount of time. For example, you can charge a capacitor and use that stored energy to light an LED. Capacitors can discharge on command. Every time you compress a button on your keyboard, say you hit the W, the enter key, the space bar, it commands a capacitor to discharge, and that initiates a process in the circuit for some end result. Capacitors can charge and discharge quite quickly. It may be necessary to have a large amount of charge quickly available, such as a flash on a camera. Capacitors help maintain a certain voltage. Often, AC power is needed to be converted to DC power, and in the process, there's going to be peaks and valleys in the voltage. A capacitor provides additional energy as needed to smooth out the process. All right, let's take a look at what is going on physically. On the level of an electron, what is happening so that these neutral plates end up being positively charged for one plate and negatively charged on the other plate, and thus storing electric potential energy. When we connect the capacitor to both the positive and negative side of the battery, the electrons experience a force and they'll begin to move. They'll start to be accelerated due to the electric forces they're experiencing. Remember that the plates are metal, so they're a conductive material and they have free electrons that can move. Remember, the wire is metal and has electrons in it that are free to move as well. So when we attach a capacitor to the battery, the side that is connected to the positive terminal will attract electrons to it. And so as one electron leaves the plate and goes towards the battery, the top plate has now become less negative, or it becomes positive. Now that we have a positive plate, it attracts electrons to it. So from the battery going towards the bottom plate comes an electron, and now the bottom plate becomes more negative. And so this gets a negative charge on it. Then another electron leaves the plate attracted to the battery, and another electron leaves the battery going to the plate, and then another electron leaves the capacitor going to the battery, and then another electron leaves the battery going to the capacitor, and so on by the quadrillions. The net effect is that the top plate will end up with a positive charge. And since it was a one-to-one give and take here, the bottom plate will have equal value of charge, just negative. Now that we have stored charge of opposite sign on either plate and they are separated from one another, there's going to be the voltage across them. There's going to be stored energy between them. And now the question is going to be, when does this charging process stop? When do the electrons stop going from the battery to the capacitor's bottom plate and from the capacitor's top plate to the battery? Okay, so the battery has a voltage. Let's just give it a voltage, a number of 9 volts. And initially, the capacitor has a voltage across it of 0 volts. Then the charging process begins. And initially, the voltage between the two, right, from the battery to the capacitor is going to be, well, 9 minus 0, and you have 9, right, between the two. Then sometime later, the capacitor is now going to be at, let's say, 1 volt, 2 volt, 3 volt, and as the voltage across the capacitor increases, the voltage between the battery and the capacitor decreases. 9 minus 3 is 6 here. Sometime later, the capacitor gets fully charged, and the capacitor will have a voltage across it of 9 volts. The battery still is its 9 volt. And now we see that the voltage across the battery to the capacitor is 0, and that is when the electrons will stop moving, when the voltage between the battery and the capacitor has a difference of 0. All right, we'll take a look at this. Looks a little similar to what we were just looking at. However, we see that there's 2 capacitors attached to one another. This, ladies and gentlemen, is called capacitors in series, and it's what our next video is going to discuss. So be sure to check that out. I'd like to thank you so much for watching this video. Hit that thumbs up, hit the subscribe, hit the notification bell if you think what I provided was worthy. For tutoring services, make an appointment at www.getaheadlearning.net. Till next time, take care.